In our universe, almost every planet orbits a star. Earth orbits the Sun. Mars orbits the Sun. Even distant exoplanets remain gravitationally tied to their stars. But astronomers have discovered something unusual: planets that travel completely alone through space. These are called rogue planets. They don't orbit any star. They drift through the galaxy in complete darkness. Scientists believe there could be billions of these wandering planets drifting through the Milky Way alone. So how do rogue planets form? How do astronomers detect something almost invisible? And could life exist on a planet with eternal darkness? In this video, we'll explore the science behind the mysterious worlds lost in space. Rogue planets are planets that move through space independently without orbiting a star. Astronomers also call them free-floating planets, orphan planets, or interstellar planets. Unlike Earth, rogue planets receive little or no heat and light from a nearby star. This means many of them are likely extremely cold and dark. Some rogue planets may have rocky surfaces covered in ice, while others may be giant gas planets larger than Jupiter. Scientists believe rogue planets are common throughout the galaxy. In fact, some studies suggest there may actually be more rogue planets than stars in the Milky Way. If that's true, our galaxy could contain billions or even trillions of wandering worlds. Scientists think rogue planets form in two main ways. Method 1. Ejection from solar systems. The most accepted explanation is that rogue planets originally formed inside planetary systems. Young solar systems are chaotic environments. Large planets interact gravitationally with each other, causing unstable orbits and powerful gravitational disturbances. During these interactions, a planet can sometimes be thrown completely out of its solar system. This process is called gravitational ejection. Once a planet escapes the gravity of its star, it becomes a rogue planet, drifting through interstellar space. Scientists believe this may have happened many times during the early formation of planetary systems. Method 2. Formation without a star. Some rogue planets may have formed independently without ever orbiting a star. In certain regions of space, gas clouds can collapse under gravity and create planet-sized objects. However, these objects don't gain enough mass to become stars. As a result, they remain isolated planetary bodies floating alone through space. This idea is still being studied by astronomers. Detecting rogue planets is extremely difficult. Most planets are discovered using their stars. For example, astronomers observe planets blocking starlight or detect tiny movements in stars caused by planetary gravity. But rogue planets have no nearby star. That makes them very faint and difficult to observe directly. Scientists mainly use two methods to detect rogue planets. Method 1. Infrared detection. Young rogue planets still produce heat from their formation. This heat can sometimes be detected using infrared telescopes. However, older rogue planets cool down over time and become much harder to observe. Method 2. Gravitational microlensing. One of the most important detection methods is gravitational microlensing. According to Einstein's theory of relativity, gravity can bend light. When a rogue planet passes in front of a distant star, its gravity briefly magnifies the starlight. Astronomers can detect this temporary brightening and use it to identify the planet. This method has helped scientists discover several rogue planet candidates. One of the most famous rogue planets is PSO J318.5-22. It is located about 80 light-years from Earth. Scientists estimate it is several times more massive than Jupiter. This rogue planet is relatively young, around 20 million years old, and still glows from internal heat left over after formation. Discoveries like these help scientists better understand how planets and stars form. At first, rogue planets seem completely unsuitable for life. Without sunlight, surface temperatures would be extremely low. However, some scientists think life could still be possible under certain conditions. A rogue planet with a thick atmosphere could trap internal heat. Heat generated from radioactive materials inside the planet may also warm the interior. This could allow underground oceans of liquid water to exist beneath thick layers of ice. Similar environments may already exist in our own solar system. For example, scientists believe moons like Europa and Enceladus contain underground oceans beneath icy surfaces. If microbial life can survive in such environments, then rogue planets may also have the potential to support life. Rogue planets travel through the galaxy over millions or billions of years. The possibility of one entering our solar system is extremely small, but scientifically possible. A massive rogue planet passing nearby could affect gravitational stability in the solar system. It could potentially disturb comet belts or alter planetary orbits. However, there is currently no evidence that a rogue planet is approaching Earth. Scientists continue monitoring space using telescopes designed to detect faint moving objects. Rogue planets are among the most mysterious objects in astronomy. They challenge our understanding of how planets form and survive. These wandering worlds travel through the darkness of interstellar space without a star to orbit. Some may be frozen and lifeless. Others could contain hidden oceans beneath icy surfaces. As telescope technology improves, astronomers may discover many more rogue planets in the future. And each new discovery could reveal more about the hidden worlds drifting silently through our galaxy.